So first, I'm going to tell you a few things about myself, as opposed to giving you jokes. People tell me that my life is quite colorful. So I was born in Istanbul, Turkey. Istanbul is a beautiful city. I recommend that you make an effort to visit and see. I was born in 1950, so I'm in the process of making 75th trip around the sun. And we are all actually in the same boat called Earth for making that trip around the sun. I'm proud Canadian as well as proud American. And these days that's important to mention. And I'm proudly secular as well. Again, important for me to mention that here. I'm married. My wife was here last week, married for 49 years. So 50 is coming next year. I need to do something. I'm open for suggestions. I have a daughter, Melissa, and a grandson, Aiden, and he is 3.5. And in this picture, you can see his cheeks are red because he had just come in from tobogganing. And we had 4 feet of snow where we live. And he, of course, enjoyed it a lot, not me. I'm not into astronomy from a professional point of view. I'm a computer scientist. I did my PhD on it, especially computer networking, ARPANET. Some of you may remember ARPANET, predecessor to Internet. That's from University of Waterloo, Canada, and that's the Canadian connection. I worked as a scientist. I'm a scientist. I worked as a corporate executive. I was CTO of British Telecom in London. And last 10 years of my career was investment banking, merger acquisitions, and fundraising. I lived in Ottawa, in Canada, Tokyo, quite a few years, learned Japanese, London with British Telecom, and Dallas. We spent most of our life in Dallas before we moved to Denver. I retired 10 years ago, and I'm also a 10-year survivor of cancer. And those two are not, they are related, they are not unrelated, I should say. And I became an amateur astronomer after that. I bought myself first telescope. I always was interested in astronomy, never had the time. I did have the money, but not necessarily the time. After retiring, I decided that I need something to do. I have been with DAS for 8 years. When I joined, it was about 500 or 600 members. Now it is double, 1,200 members. We are probably the largest recognized amateur astronomy club in the country. I was a trustee for a year. And I was vice president twice, 2 years. And my vice presidency ended last Saturday. So I'm now an ex-vice president. So, starting with astronomy, since this is naked eye astronomy, well, we have to go way back to ancient astronomers. You probably know the Chinese, the Greek, Roman, Arabs, Hindu, Mayan, and various indigenous groups. Indigenous astronauts contributed to astronomy in a very big way. You can see their work on Google or in books. Lots of stars and planet names. They were named by these ancient astronomers. And they are either Roman names, Greek names, or Arab names. And some stars, as you'll see, have multiple names for different cultures or different old astronomers or ancient astronomers named them differently. So, in a sense, you don't need a telescope or binoculars to learn, to appreciate, and to enjoy astronomy. You can buy a telescope or binoculars, but you definitely can start without one. So this chart is very important for you to understand, and John last week touched on this, but I'm going to build on this quite a bit. This is the brightness of objects in the sky spectrum or range. Now, this is actually based on what is called reverse algorithmic scale. Sun is minus 27. Moon, full moon, and we had full moon just a few days ago here, minus 13. Venus is the brightest planet, and I'm going to get into Venus a bit later, 4.5. Jupiter is the second brightest, minus 3. Mars, right now this year in January, was the closest to us, Mars, and that was minus 2.9. Sirius is the brightest star beyond the planets. Sirius is the brightest star, and it is visible now in the spring. Vega is the one that is right at zenith, at the top of you, in the summer. And it is about 0. And I have a theory that whoever decided the scale started with Vega as 0, which may or may not be true, by the way. But Polaris is, you probably know, North Polar star. Polaris is not that bright, but it is relatively easy to find, and it doesn't set or rise. It's always in the same place, and we can discuss why. It is plus 2. Now, this number is quite interesting, 6.5. This is where your limit is. Actually, I would argue that the limit is lower than that. It is around maybe 5.5 or 6. It depends on how good your eyesight is, where you are, how dark it is, and so forth. Hubble telescope, you probably know, is plus 30. And the most recent James Webb is beyond that, 34 or more. And it has an infrared and so forth. That's why it can go beyond 30. Now, I want to touch on Greek astronomer Hipparchus. He is the one, I believe, who started this scale. Now, John indicated last week that we may not know who exactly did it, which is partially true, but this Greek astronomer who was born in Iznik, which is on the western part of Turkey, and I visited that place last couple of years ago with my wife, and lived in Rhodes. Rhodes is a Greek island in the 2nd century BC. He came up with this 6th magnitude of star brightness. So this scale is actually based on that. He was considered the father, or he is considered the father of astronomy, as well as trigonometry. Trigonometry, if you don't know, is part of geometry or maths. Now, this is not only you need to know this, but you also need to know this. I was afraid to put a formula here because that may scare you. But this is 5th root of 100. What that means is between the two numbers, the difference is about 2.5, but between 5 numbers, it is 100. So for example, if you want to go from 0 to 5, it is 100 times brighter. If you want to go from 0 to 5, plus 5, it is 100 times dimmer. So if you do the math, you can find that Hubble with 30 plus 30 is actually 400 billion times more powerful than your eyes. In other words, Hubble can see 400 billion times fainter objects than our eyes can see, okay? And in practice, when somebody tells you it is 4.5 or 5 versus Vega, you can tell it's about 100 times fainter. So in this case, if you approximate this, Venus is about 100 times brighter than Vega, okay, or close to 100 times, because that one is 4.5, the other one is 0. Okay?
So
0 to 1 would be 2.5 times. So if you go 1 up or 1 down, that's 2.5. If you go 5 up, that is 100. Okay? And that's what this formula is, the fifth root of 100. You know, root formulas are like this. Anyway, I didn't want to put a formula here. But in any case, you need to know this because when people tell you, oh, the brightness of so-and-so is 3 versus 7, you need to calculate how faint certain objects are. Okay? Now, the main problem that you are going to have living in a city or versus those ancient astronomers is we have electricity. And because of electricity, there is significant amount of light pollution. And this is not just damaging astronomy or our ability to see, but also various health implications and wastage, energy, and so forth, okay? But there are some initiatives underway to reduce the pollution, the light pollution. And you might have heard, if you haven't, you should check them out, Dark Sky International. These guys have come up with various light practices, like lights in front of your garage should be facing down, not facing up, as an example. Or lights everywhere should be only focused on where they are the most efficient, and so forth. Now, DAS offers a dark side. One of the major advantages of DAS membership is ability to go to dark sides. And this dark side, Klein Dodge dark side, is about 60 miles east of here, of I-70. And our members frequent that place, and some actually become members just to be able to go to that dark side. Now, we have another collaboration, this one with Douglas County. This is called Sandstone Ranch, about 45 miles south of here, of I-25. And through this collaboration, you can also, DAS members can also take advantage of the dark side. It's called Sandstone Ranch, okay? So to enjoy astronomy, you may need a dark side. Now, not only for naked eye, but for telescope and binoculars, you still need dark side. So don't think that by buying a telescope you can stay in your condo in downtown. You may, but you'll be quite limited. Okay, this picture was taken in Toronto during the great Northeast blackout. Now, I don't know whether you folks remember it, but I do. Back in 2013, there was a blackout which covered New York, Vermont, Ontario, and so forth. And this picture was taken before and after the blackout. And exactly the same picture. You see, here you cannot see the Milky Way. Here you can see so many stars and the Milky Way. And this tells you the impact of light pollution. This tells you the advantage of dark side. DAS's dark side or Sandstone Ranch dark side. You will see the Milky Way if you go to those two dark sides. If you are in your condo looking out from the balcony in Denver, this is what you will see. Okay? No telescope will help you. Now, John also touched on the angular astronomy or angular measurements. I want to go into more details with that. So we use astronomers, both professional and amateur astronomers, use angular distance between stars, between constellations, or within constellations. We don't say, oh, go 5 centimeters or 5 inches, but we use angular. Now, this one, okay. So as actually John mentioned, 1 degree is 60 minutes, or arc minutes we call it, or each arc minute is 60, so 3,600 arc seconds is 1 degree, okay? So a good example of, as a reference, is the moon or the sun. They happen to be about half a degree, or 30 arc minutes. This is important to know, 30 arc minutes for the moon or for the sun. Now, I would encourage you to use your arm. Extend it as much as you can. Pinky finger next to your ring finger, that is 1 degree. So if something is 1 degree apart, and your arm and your thickness of your finger will correspond to each other, that is 1 degree. If you use 3 fingers of your right hand, that is 5 degrees. Okay? If you use your fist of your left arm, 10 degrees. And like that is 15. And this is 25. So if something is 25 degrees, for example, Jupiter last night was about 25 degrees from Betelgeuse. I'll come to that a bit later, but 25 degrees apart. Use your hand and your fingers to experiment with it. Now, the first thing I would encourage you to study is the moon. It is the most prominent thing in the sky, obviously, and you can see it even from your condo balcony in Denver. So there are 2 areas on the moon to look at, and you'll see them very clearly. Dark areas, gray areas, I should say, and the white areas. Okay, that should be very easy to do. Now, the gray areas are called Maria or lunar seas, or let's call them seas. Okay, there is no water or seas on the moon, but they are named like that. These are basically asteroid or meteorite hits and filled with erupting lava, and they are darker because of that. The whiter areas, which is actually at least half, maybe more, those are called highlands, and they are mostly made up of white minerals and so forth. Now, there are major craters that you should be able to identify. These are, again, test of your eyesight. Copernicus is over here, and it's probably first thing you should look at on the moon. Where is Copernicus? Okay, Kepler is just next to it, left of it, and then Aristarchus is above it, over there. Now, the Tycho, I mentioned Tycho here, but the name is missing here. Tycho is at the bottom. Okay, these are Tycho might be difficult to spot, but you should definitely spot this one. Copernicus. It's probably the biggest, and it was formed, I believe, most recently. Now, I also want to, okay, let me see, yeah. But before I do that, let me ask you whether you know where Neil Armstrong landed. Anybody knows? Yes, it is in Tranquility Base over here. Now, you should be able to spot this and show it to your kids or whatever, just to impress them, that the American flag is there. You may not be able to see it. Nobody is able to see it, but Neil Armstrong landed here in 1969. Okay? Now, the other question is, we have Artemis 1 that was launched. Artemis 2 is coming next year. Artemis 3 date hasn't set yet. But do you know where Artemis 3 is going to land? No. Artemis 3 is going to be the first mission, of course, since 1972, sending man to the moon and woman to the moon. First woman landing on the moon will be near South Pole. They identified 13 sites around the South Pole, and Artemis 3 is targeting one of those 13. Now, the other thing about the moon is we have this tidal locking with the moon. And because of that, this synchronous rotation happens. In other words, we only see the same side of the moon. Moon doesn't spin around itself. It spins together with rotating the Earth, rotating around the Earth. And that's called tidal locking. And that's actually what creates the tides. We have all these tides, and that's thanks to the moon. Now, this picture shows you different phases of the moon, but you probably know this, okay? You know the new moon, the crescent. We call it waxing crescent in the beginning, waning crescent at the end. And full moon is we just had full moon recently. One thing to keep in mind is full moon is when lunar eclipses happen. Because if you look at it, Earth is between the moon and the sun. And solar eclipses happen when it is most likely when it's either new moon or no moon. In other words, you don't see the moon. And in those cases, the moon is between the Earth and the sun. And I'll come back to this topic a bit later. But this diagram not only shows you the different phases of the moon, and this takes, by the way, 28 days, and you know that, am I right? But also it shows you the rotations of the moon around Earth and how we happen to see waxing or quarter moons and so forth. Now, coming to the solar system. Our solar system had 9 planets when I was growing up. Now we have 8. One of them was dropped. You probably know, Pluto. So we have 8 planets. We can consider 7 of them out there. We call them rocky planets, Mercury, Venus, Earth, and Mars. These are solid rocky planets. We have gas giants. They are mostly helium, hydrogen and helium gas. And those are Jupiter and Saturn. I'm going to talk about these planets in more detail. The ice giants are the last 2, Uranus and Neptune. They are ice giants because they are extremely cold. Now, with naked eye, you should always be able to see Venus, Mars, Jupiter, and Saturn. Now, I left out Mercury, but actually you can see Mercury too. It's just that it's more difficult. It is too close to the sun. You have to know exactly where it is. And so Mercury is also visible to naked eye. But also Mercury is very small. It's smaller than our moon. Okay? And because of that, it is difficult to spot. Now, Venus is the brightest planet due to the dense cloud cover. It has actually 3 layers of clouds. The clouds go around the planet. There is a rotation of the clouds. three layers of them, and they complete that turn in 4 Earth days. Because of those clouds, it is bright. So it is not because it reflects more or whatever. Those clouds are the ones that reflect the light from the sun. It is between the sun and us, so it is somewhat visible before sunset or after sunset or before sunrise. After sunset you can spot it, and before sunrise you can spot it easily. It's the brightest object in the sky. Well, I already said that. Now, there are several trivial facts. If you play Trivial Pursuit or whatever, the name of Venus comes from a Roman goddess, you probably know, goddess of love and goddess of beauty. That's how the female association with Venus comes on. Venetian day is about 242 Earth days. In other words, it turns around itself in 243 Earth days. Venetian year is 224 Earth days. So if you do the math, Venetian day is longer than Venetian year. Okay? Which is very unique to Venus, by the way. The other thing unique to Venus is it spins the other way around, not in the Earth's direction. In other words, the sun rises on Venus on the west and sets on the east. So if you live on Venus, not only you are going to have very, 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 very long days, the sun is going to rise on one side, west, and set on the east. Or maybe you have to change the names. Venus has lots of volcanic activities. Now, you won't see them when you look at Venus, but it might be important to know that Venus is actually a very, very active planet. They have lots of volcanoes, it's 400 plus degrees on the surface, and they have quakes, Venus quakes. They are like our earthquakes, but instead of shaking like this, it shakes like this, like an elevator going up and down. Another uniqueness of Venus. Mars. Now, there's lots of talk about going to Mars, so you should actually learn more about Mars in case, if not you, but your kids or your grandkids are thinking of going to Mars. So the surface is red. Okay, there is no doubt about that. When you look at Mars, actually I took this picture, you can see the red color here. Okay, red is Mars. Mars is red. And the reason for that is the iron, rusty iron oxide on the surface. And it's called a red planet anyway. I mean, that's the name of the planet. Mars is the red planet. And the name of Mars comes from blood, war. The Greeks named it Mars because Mars is their war goddess, or god, I should say, not goddess, but god. And since it is red, they said, oh, it is blood, so it must be war. So the war god is Mars in Greek and Roman mythology. Mars has a rather elliptical orbit. Our orbit is not that bad, but Mars actually has a very, very elliptical orbit, and it varies. The distance between Mars and Earth varies quite a bit, and it was very close to us. March 12th this year, and I took the picture on January 12th, and I took the picture January 14th, 2 days after it was the closest to us. Now, that happens once every 2 years, or actually 26 months. So every 26 months, Mars comes close to us. So the next time will be in 2027, in case you want to consider that. So I already told you about the name. Mars has lots of similarities with Earth. Mars' day is 24 hours and 40 minutes. How close can that be? It is called Sol, S-O-L. Martian day is called Sol, and it is 24 hours, 40 minutes. Okay? Year, of course, can't be the same because they are farther out from the sun. It's about 680 days long. So it is close to 2 years for us. The size is about half the size, but the solid, since there is no sea, the amount of surface on Mars is equal to the land surface of Earth. So if you are going to buy some parcels of land, well, it's about the same surface as Earth. Their atmosphere, however, is very, very thin, 1% of our atmospheric pressure. 1%. And as you probably know, there are so many rovers on it. There are five NASA rovers. Now, they don't work anymore, but they are there. And there's a Chinese rover as well. I don't know whether that is working. And there is a helicopter. And that helicopter flew several times, even though it's such a thin atmosphere. So it was a miracle, in a sense, that they managed to fly that helicopter on Mars. There is a term here, conjunction. Conjunction means when two space objects are very close to each other. So in this scenario, the Moon and Mars were very close on that day, on the 14th. That's why I took the picture, not on the 12th, but the 14th, to capture not only Mars close to us, but also the conjunction. So that's Moon over there. You cannot tell because this is taken with my cell phone. Now, Jupiter. As I mentioned, Jupiter is a gas giant. It is the largest planet. Actually, if you put all the solar planets together, Jupiter is 2.5 times that. It is huge. And it's very easy to spot. Next to Venus, Jupiter is the second easier planet to spot. It is called a failed star. What that means is this guy could have been a star if it were 80 times bigger. Failed because if it were 8 times bigger, it could have generated what the star does, because it already contains the hydrogen and helium, which is what the sun contains. It has a significant magnetosphere or magnetic field. So in a sense, it could have been a major star, and there are some science fiction movies as Jupiter being more than just a planet. One thing that's very interesting is Jupiter being so huge, it spins very, very, very fast. In other words, in 9.9 hours are Earth hours. And that speed creates the magnetic field. It is huge magnetic field that affects everything around Jupiter. It has many moons. More and more are discovered. The latest number is 79, but if you are looking for something to do, you could explore. As a matter of fact, some Canadian astronomers came up with another set of moons around Jupiter. Now, discovery of moons started with Galileo in year 1610, if I remember correctly. And there were more than just Galileo finding these moons, but nevertheless, they are called Galileo moons. The moons, there are 4 of them: Io, Europa, Ganymede, and Celestio. Yeah. Now, their brightness is 4.6 and 5.6 range. So in theory, you should be able to see them by naked eye. The problem is they are too close to Jupiter. And this sky is so bright, and it is possible to see them with a binocular. As a matter of fact, when we talk about binoculars, I'm sure they are going to tell you you can spot the moons of Jupiter with a binocular. In theory, it is also possible to see them if you are in a very, very dark site. But even Galileo needed the telescope to spot them, okay? And Europa is the most interesting one. It is the smallest of the 4. And there is a mission underway to Europa right now, started last October, I believe, called Clipper. Is it Clipper? Huh? Yeah. Clipper mission. And it is going to arrive there in 2030. And it's going to explore Europa's water under the ice. This moon is covered with ice at the top, but the water under it, the seas under it, can be as deep as 100 miles. So one theory is, or one argument is, that there is more water on on Europa than the water on Earth, and there may be some alien life in that water in the seas of Europa. And this particular mission, Europa Clipper mission, is to explore that. You can read about it. I think there was a Mars slingshot it's called, just recently on March 1st, a couple of weeks ago, because it is using that slingshot to get to Europa. The Clipper mission is huge. It's a basketball-size mission unit, and so they are trying to save from fuel using the slingshots of Mars and Earth later to swing to Europa, to Jupiter. Anyway, that's just for you to know in case somebody asks. So the other thing about Mars, which you won't be able to see with naked eye, but when you get a telescope, or if you have a telescope, you can look for this great red spot, which is somewhere in the equatorial area of Jupiter. And it's very huge. It is turning very fast, and it's a major storm that has been going on for the last more than 100 years, I believe, 100 plus years. Saturn is the planet with the rings. You must have heard Saturn and its rings. It is the second largest planet. Again, it's a gas giant, hydrogen, helium. It has many rings, not just one. We name the rings as A, B, C, D, E rings. You can see the rings with a binocular. You cannot see the rings naked eye. So this picture is not naked eye picture. There are also many moons of Jupiter, of Saturn. But the most interesting one is Titan. As a matter of Titan, I believe is the second or third largest moon of the solar system. And it is considered most hospitable solar object other than Earth, because it has a magnetic field, and it has an atmosphere, and it has liquid something. So it has some lakes, in other words. And there is a mission to Titan planned called Dragonfly. And Dragonfly is, if it is funded properly, will go out in year 2028. In other words, 3 years. And it's targeting Titan, specific to Titan. Saturn is similar to Jupiter, also spins very, very fast. Instead of 9.9 in that case, now this is 10.6. So it's very fast. Spin, such a huge gas giant, but spins very fast. And the rings around it, of course, turn with it. Okay, what is the difference? Oh, 45. Okay, let me, give me a few more minutes. What is the difference between stars and planets? This is somewhat important, especially if you can distinguish them. These differences are, stars are not as bright as the planets. Planets, the ones I mentioned, the Jupiter, Venus, and Saturn, are brighter than all the other stars. They don't, planets don't twinkle. Stars do. So if your eyesight is good, you can tell something is twinkling. There is something called ecliptic. Ecliptic is the path that the sun follows. You probably know where the sun goes, okay? That is called ecliptic. And planets are, almost all of them are on that ecliptic. So if it is away from that ecliptic, it is definitely a star. Of course, there are stars on the ecliptic as well, but my point is planets are going to be on the ecliptic. And they move from one night to the next, or from 1 month to the next month, because even though it's a very slow movement, the stars don't move. Stars are in the same formation as what we call constellation, and I'm going to come to that a bit later. But planets will move because they are going around the sun, and they are not necessarily stick to or stuck with a constellation, okay? Now, in addition to observational differences, there are huge differences between the stars and planets in physical terms. And I'm not going to get into that. That's the actual astronomy. One of them, of course, produce fusion or fission. No, fusion. The others are just either dead chemical reaction-wise. Maybe I'll do this chart and then I'll give a break, okay? Now, the stars are rise in the east and set in the west. Not because they want to, it is the Earth's rotation, okay? When you see the sun rising or moon rising, well, the stars rise in the same place because of the Earth's rotation. Now, there is 4-minute rule. Stars move 4 minutes earlier each day. This is important to know. And that is because of the trip that the Earth makes around the sun in 365 days. So this 4-minute earlier each day is because the Earth is moving around the sun, and that 4-minute gap or 4-minute earlier phenomena is created. And I'll explain this later to you when we look at the individual constellations and so forth. How many stars can you see? Now, I'm not suggesting you count them, but you can. I mean, it is possible if you are in a dark site, you can count maybe hundreds of stars easily. They say it is at least 3,000 stars visible to naked eye. Some people even argue that it is around 9,000. So it depends on how dark it is, how good your eyesight is, what type of light pollution there is, or whatever. But you should be looking at hundreds, if not thousands of stars, potentially, if you are in a dark side. Now, all the stars that you see with your naked eye, is within our own galaxy. You will not see any star outside of our galaxy, or Milky Way. That's almost impossible, or impossible. Stars form some patterns. They are imaginary shapes, either animals or people or whatever, and they are called constellations. For example, Orion is a constellation, okay? And we are going to look at constellations a bit later. Now, there is something called asterisms, and they are confused by most people. These patterns are with stars either within the same constellation or stars from different constellations. They just form shapes that were found very interesting by the ancient astronomers. And Big Dipper, which lots of people are familiar with, is actually not a constellation, it's an asterism. Okay, so maybe I'll stop here, give you a 15-minute break. Feel free to look at these books. This might be the only chance. And then we'll meet in 15 minutes. Okay? So Milky Way, we touched on this before, is visible like this if you are in a dark side. It contains our solar system. It is what we call galaxy, okay? And it is a spiral galaxy, and Sun is located in one of the spiral arms, okay? Name describes the appearance from the Earth. Now, the Greeks had a goddess called Hera, I believe, Herodes's mother, whose milk, breast milk, spilled. And they named this Milky Way because of that breast milk spill. So in case you want to know why it was named Milky Way, Greeks came up with that. Now, you can actually see Milky Way year-round. It might be more challenging sometimes, but the summer is the best time. Summer and the fall. It is more difficult, I think, in the winter. There are calculations made that our Milky Way is going to smash into another major galaxy. By the way, our Milky Way has about 200 billion stars. Andromeda galaxy, which is much bigger, I think 500 billion stars, if I'm not mistaken. They are going to collide, or we are going to smash into them. But don't worry, the solar system will survive that smash. Okay, solar system will stay intact. Now, coming to constellations, we mentioned what the constellation was. It's a group of stars that form a pattern or imaginary shape in the sky. They are named after animals or whatever, people or objects. We use them, astronomers, amateur and professional, use them to navigate the sky, or find the stars. So a star being part of a constellation, you find the constellation and then you find the star, or you go from one constellation to the next constellation. The IAU, which is the Astronomical Union, recognizes 88 constellations. And I was explaining this a bit during the break. Stars within a constellation have nothing to do with each other. They just appear from our vision. They are together. but they are not necessarily related to each other or distance-wise, completely different, and so forth. So there is almost nothing to do with each other except from our point of view, from our line of sight, they happen to be forming a shape that we call that particular constellation. And this is some of the favorite constellations that I want you to maybe find out. Ursa Major, Hydra, and so forth. You can see Orion, as we mentioned earlier, Scorpion, Leo, Cassiopeia is an interesting one. I will show some of these to you a bit later, how they look. But there is a list of all these constellations you can find. Meteor showers. This is another thing that you can see with your naked eye. What are meteor showers? First of all, you may actually see a meteor burning. This is like a shooting star, it's called. Almost every 10-15 minutes. So if you really look outside any evening, in 10, 15, 20 minutes, you should be able to see at least one on average. But during a year, Earth passes or crosses some debris left from comets. I'll come to comets a bit later. But when the comets come, they leave some debris, and Earth passes their path during a certain time around the sun. These particles, these debris, create the meteor shower. So when somebody says meteor shower, the Earth must be passing through the debris left by a comet some time ago. And they are named not from the comet, but from the constellation they appear to be coming. This is the confusion. So they may be created by one comet, but they are not named after that comet in the case of meteor showers, but they are named after where they appear to be coming, which constellation they appear to be coming from. And some meteor showers may have 50 to 80 per minute, or per hour, not per minute, per hour. Almost one a minute. So some meteor showers, this picture is not an actual picture, this is composed. But some meteor showers are more intensive. And some of them are very bright, like as bright as Venus. And maybe more interestingly, some of them explode. So it is not just a streak of flying, but explosions. Now, how to observe a meteor shower? You find a dark location, okay, always. You have to adjust your eyes, lie down. If you have a camping cot or something, and you look up and hope that you'll see. Of course, you have to dress warm and so forth. This is the meteor showers that we go through. As you can see, these names are constellation names, and or the version of constellation names, and they actually gives the name to the shower, to the meteor shower, and these are the dates, and those are the hourly rate, maximum hourly rate of meteors. As you can see, this Perseid shower is one of the best here. There are a few others, but this Geminid is another one. Okay? So one of the reasons why I like this, of course, is in the summer. Okay? Comets. Comets are icy objects that orbit the sun in an elliptical orbit. They come from outer solar system, what we call Oort cloud. and they come to the inner solar system. And when they come closer to sun, the outer layers of the comet starts melting, and they evaporate from the tail. In other words, comets don't have tails until they come close to the sun. And some comets have less than 200-year periods. In other words, their elliptical orbit is less than 200 years. Astronomers pick this 200-year as a demarcation. Halley's comet that you might have heard visited us in 1986. I believe March of 1986. It has about a 75 or 72, 75 year period. So the return is going to be in 2061. I may not be able to see it, but maybe our grandkids may. Now, some comets are thousands of year orbits. They are far, far away, and they take thousands of years. As a matter of fact, we had one comet just in October visits us in 80,000 years. Once 80,000 years. And this one is called Suchin-Chan Atlas Comet. That came in October. As a matter of fact, this picture was taken, one of our members, Ron Hernak. This is from his front yard. Comet is here, as you can see, taken with the iPhone. So you can definitely see the tail very nicely. Here is the same comet. Now, this picture shows three things. This is a Milky Way here. This is Venus. And this is the comet that I just mentioned that comes 80,000 years. Okay? Taken by this fellow in California. Again, naked eye view. Now, this one is the same comet. This is that comet. This is a meteor shower. And interestingly, that meteor shower is Oranid meteor shower, which is left over from Halley's comet. So here you have a comet that comes 80,000 years, once in 80,000 years. This is the remnant of a comet that comes every 75 years. Again, this is a naked eye view taken taken here in Arizona, Tucson, Arizona. Okay, next thing I'm going to talk about is Northern Lights. I'm sure you know what Northern Lights are. Some people are lucky to see them. Some people... A friend of mine traveled to Iceland last month to see Northern Lights and came back complaining that it was raining all the time. So they are called Aurora Borealis, the Aurora Borealis for the Northern Lights. It is thanks to the magnetic field that Earth has. You see, the sun has flares and these CMEs, coronal mass ejections, that come out. And these solar winds are diverted to the North Pole. And these activities, these Northern Lights as well, have a cycle. The cycle is about 11 years, from the least to the maximum. And the maximum activity is going to happen July this year, summer of 2025. So we will see huge amount of solar activity, lots of sunspots and flares, and hot plasma going into sky, into the space, and Northern Lights. Now, there are implications of this, especially affecting the satellites. The GPS satellites or any satellite. navigation systems and spacewalks will get very dangerous. Now, this only doesn't happen in the north, it also happens in the south, and they are called southern lights, obviously, at the South Pole. Now, I want to tell you about the sky changes, spring, summer, fall, and winter. Since Earth moves around the sun, we see different constellations and different stars on where we are in the orbit. This is due to the tilt that we have, 23-degree tilt, which also creates the seasons. Okay, you know that. So the sky map changes. As a matter of fact, most of these books or magazines and so forth give you different sky pictures for different times of the year. There are tools, the night sky planisphere, this thing that you might have seen, actually created by one of our members, David Chandler. They help you to figure out, depending on the season, the time, day, time, and where to look, what latitude you are, and so forth. And so there are monthly and seasonal charts. So let me start with the spring, since we are in the spring now. Okay, so Leo, over here at the bottom, is the major constellation here in the spring. You should be able to see it. There is a spring triangle, Regulus here, Spica, and Arcturus. Those three form a triangle. That's what would be called spring triangle. Regulus is the brightest of this, 1.35, and it's a variable double star, but also happens to be on the ecliptic. So you heard you know what I mentioned. Ecliptic is the path that the sun takes. So Regulus is right on the ecliptic, and that would help you to find the triangle. Here, Ursa Major is the largest constellation at the right corner there, and the Big Dipper. Big Dipper is this one. It's the asterism, and it has the Miser star, which is a double star, right at the corner there. And here, there is in this chart, it tells you how to find Virgo, using the orientation of the Big Dipper, and it comes like that. Again, using angular positioning. Summer. The summer triangle is even more visible. Vega is right near the zenith. Zenith is the top. Vega is very close. Deneb and Altair. And near Deneb is the North Star. Oh, sorry, North Cross. Sorry, North Cross. This is the North Cross. Very, very visible again in the summer. You should be able to see where Northern Cross is. And that tells you where the triangle is as well. One of the things about Vega is that astronomers, especially early astronomers, use Vega as the way to calculate the distances and the brightness, as I mentioned to you before. So they use that for calibration purposes. I mentioned to you the meteor shower in August. Now, there is this keystone perfect square here, Hercules constellation. That keystone is very visible again because it's a square. Squares are easy to locate. And actually, it says perfect square, but may not be perfect, but it is close to it. And summer is the best time to see the Milky Way. And as you can see, Milky Way is shown as a shaded area here. Oh, before I should have mentioned this to you. Maybe I go back. Can I go back? Okay. This here is very interesting. These charts are shown for a given time of a month, and then the next month it is 2 hours earlier, and then 2 hours earlier. So if we look at, let me take the April first. Mid-April, it is 12 a.m. Mid-May, it is 10 p.m., so 2 hours earlier. And that is because of that 4-minute earlier calculation. If you multiply 30 days with 4 minutes, you get 2 hours, 120 minutes. So the difference between April, mid-April to mid-May is 2 hours. So this thing is 12 o'clock, mid-April, 10 o'clock p.m., mid-May. Now, this guy was smart here. He put, what you call, summertime or daylight saving time change reflected here. So mid-March, it is before the change of clock, so 1 a.m. This actually should be 2 a.m. And then this is 12 a.m. And then this is 10 p.m. It's going 2 hours earlier. So if you go to here, it is the same. During the summer, you have mid-June, 2 a.m., mid-July, 12 a.m., mid-August, 10 p.m. Okay? Most of the things in the magazines or in the books or on the web are going to be given to you with this type of timing explanation. So autumn, the most interesting one is Cassiopeia. That's very easy to spot, a bit northernly positioning, but it's a W. Okay? You should be able to see W very easily right away. The Great Square of Pegasus. Actually, this is a more perfect square. And that's also Pegasus square. There is actually an eye test here. How many stars can you count within the Great Square of Pegasus? If you can count 10 or more, you are good. Okay? If you cannot see any, you are in trouble. But there should be at least 5 or 7 or very easily to spot. If you can spot 10 or more, your eyesight is very good, or you are in a good dark side location. Andromeda Galaxy, I told you 500 billion, actually 300 billion stars. It's right over here. There's a constellation around it. By the way, sorry, the magnitude is 3.3, but seeing the galaxy itself is very difficult because it is not in one place, it is more like a cloud. And because of that, naked eye observing of the galaxy is somewhat difficult. But it depends on how dark it is. Algol is called Demon Star. I don't know whether you read anything about it, but that is the 3-star system. Some people even say maybe 5. This is one of the variable stars, and it is variable potentially because the stars are going around each other creating eclipses. And it is Perseus constellation, again, next to Cassiopeia, is very easy to spot. Fishes, there are two fishes according to one going this way, the other one going that way, they say. I cannot figure that one out. And there is the October meteor shower in the autumn skies. And Leonid meteor shower, I think I mentioned that. That is more prominent. Winter skies, going out in the winter is a bit more challenge, but Orion is the most famous constellation. There is actually a nursery rhyme, they tell me. I never heard that before, but 3 stars in a row, 2 above and 2 below. That's the 3 stars, the belt over here. Betelgeuse is here, and Rigel is over here. These are the 2 bright stars. This is actually orange color. Rigel is very bluish, brightish, whitish star. Betelgeuse is red giant, Rigel blue-white supergiant. This nebula, okay, there is a nebula here. This is one of the nebulas that you could see with your naked eye. It is magnitude 4. It is just below the belt, the 3-star belt on the left-hand side. And again, it should be an ice test to spot that nebula. Castor and Pollux are the twins, Gemini up there. Castor is a 3-star system. When I say 3-star system, either one of them is very, very bright, the others are dim, and they are rotating around each other, or they may be actually more than one of them bright. 7 Sisters is a very easy to spot again. Pleiades, they have multiple names. There is more than just 7 stars. Actually, hundreds of stars in that system. Again, easy to see with a naked eye. Capella at the top, double star system. Aldebaran is red-orange, it's over here. In the Taurus constellation. It is magnitude 0.87, so it is very bright. And you may or may not know, Pioneer 10 that was sent out in the 70s. Am I right? 70s. We'll get there in 2 million years. It was targeted that particular star, which is 65 light years away. Incidentally, Sirius is the brightest star in the sky, and it's visible in the winter. Again, you may confuse that with a planet. It is that bright. Let's talk about eclipses. Solar eclipse is when the moon is between the Earth and the sun. So the moon casts a shadow on Earth, or part of the surface. There are 2 terms that are used. You may or may not need to, but umbra is the darkest part. You don't see the sun. Penumbra is outside of it. You see partial. So there are maybe 3 different types of solar eclipses. Total eclipse is moon is closer to us. By the way, the moon distance is about 240,000 miles, but it varies about 10%. So it could be about 24,000 mile difference in the closest versus farther. So in this case, the moon is closest to us and blocks the entire sun. That's what we call total solar eclipse. Annular eclipse is further away from or farthest away the moon, and you can see this part of the sun around the moon. That's called annular eclipse. And partial eclipse or hybrid eclipse is the last one, and that depends on where you are and so forth. That's a location issue and where the observer's location is. So solar eclipses require protection of your eyes. The eclipse glasses are critical, and I think you should not look at the eclipses without these solar eclipse glasses, which are thousands times darker than your sunglasses. Lunar eclipse, which we had just recently, a week ago. The Earth is between the sun and the moon. I should mention that you have umbra, penumbra here as well, partial or total. And this time, 2 weeks ago, we had, or a week ago, we had total eclipse. It was actually called blood moon. The moon became totally red because it was actually umbra here. We didn't see the moon, we just saw shadow of it or shadow of Earth on it. Solar eclipses in the future. We had one recently last year in April. Was it last year or the year before? The year before. 24 April, yeah, last year. The next one is going to be next year, August, but will not be visible here. There will be an annular solar eclipse the following year, again, not visible here. Total solar eclipse in 27 in Spain, Morocco, part of Africa. Now, there is a total solar eclipse that touches North America, but only Alaska, not continental US, in 2033. In other words, 8 years from now. The next total eclipse in continental US, if you are around, will be August 12, 2045. So this will be available or visible across the whole continent, continental US, from California to Florida, which is, what, 20 years from now? So put it on your calendars. Huh? It includes Colorado, yes. And put it on your Google Calendar. Lunar eclipses also this year and beyond. Okay, we had this one. This is just last week. Now, the next one is total lunar eclipse in September. There's no partial one. There will be one next year, only parts of Americas. Oops, that's basically it for the eclipses, okay? Now, let me talk about tools. I mentioned the night sky planisphere. This is very useful, and Dave Chandler's you can rotate it, and the sky rotates. You could figure out how to go from one constellation to the next and so forth. You can also find monthly sky charts in magazines, in books, online. Our website also has some information. There are various magazines. I brought some magazines here, and many books. You could get various books. We have various services that DAS offers, various dark sites I mentioned as well. There are also cell phone applications. Some of them allows you to hold the cell phone and tell you what constellation it is or what star system it is and so forth. Some tips for how to enjoy naked eye stargazing. The first thing is you have to dress warm, otherwise you'll be running back inside. So dress warm depending on the season, obviously. You should use red light, not flashlight, because that takes away from your eyesight. Your eyes are adjusted to the dark, and if you use white flashlight or any white light, it will take away from the adjustment that your eyes go through. So use red lights. There are red light headbands you could use if you want. You have to choose a dark site. You have to either drive somewhere or have somebody, or like DAS dark sites. You have to plan. Never go there and then try to find something. Plan what you are going to see, what you are going to look at, and know the shape of the constellation and maybe the angular distances between them. That's where the sky maps charts would help to navigate. I think what I have started myself was taking notes, writing down, once I do some observing, writing down what I saw today or this evening and what I couldn't see and wanted to see. So do take notes of your observing. It helps you next time you go out. Also, if you are using a laptop or iPad or even cell phone, make sure that you download the red screen. Because, as you know, laptops or iPhones, iPads have very bright screens, and that creates the same problem. So make sure you have the red screen for it. And as I mentioned earlier, use your hands or arms, your arm's length, to do the calculations, angular calculations. Okay? So in conclusion, I think sky is the ultimate art gallery just above us, says this fellow. So go outside and look up and enjoy it. Okay? Thank you. Any questions? Do we take questions?
Yeah. I'm going to be on a cruise of England, Ireland, Scotland, Wales, June 14th to I think it's June 16th of this summer. You mentioned the solar activity will be at its highest. Will I be able to see the northern lights from the cruise
No,
ship?
not from Mediterranean. You said
the British Isles, England, Ireland, Wales, Scotland.
Cross your fingers.
All right, okay.
You may get more rain in that area. I lived there. Yeah. We used to fly up London, outside of London, fly out to see the sun. So let alone the northern lights. If you go to Norway, you do. Okay, go to north part of Norway or Sweden. Yes, you would see it. There was a question here.
Quick question about the degrees, holding out your hand.
Say that again?
The degrees, when you hold out your hand and your finger. The chart, and you specifically said use your left hand for this and right hand. I noticed, well, was that so that other people can maybe like signal where to look, or is that arbitrary? Or?
I guess it probably is the same distance, angular distance, no matter whether it's left or right hand. I follow the picture there, left and right. That's why, but it doesn't make any difference. Any other question? Oh, okay. Well, thank you very much.
Thank you, Dr. Anzoy.